Hi everyone. In this video I am going to explain about resistance thermometer. So resistance thermometer means here it is used to measure the temperature variation in terms of resistance variation. So the resistance of a conductor changes when its temperature is changed. This property is utilized for the measurement of temperature. So the resistance thermometer working principle is an instrument used to measure the electrical resistance in terms of temperature. That is, it uses the change in the electrical resistance of the conductor to determine the temperature. The main part of a resistance thermometer working principle is its sensing element. So how the temperature sensing is could be done is the help of sensing element. The characteristics of the sensing element determines the sensitivity of the operating temperature of the instrument. So here we are using a sensing element. The sensing element, what I will tell, here we are using different sensing elements with different materials like platinum, nickel and so on. So those sensing elements changes the temperature depending upon the temperature variations, the resistance of their material will change, so that later we will incorporate this in the Wheatstone's bridge. The resistance of that Wheatstone's bridge will vary so that the fluctuation will be shown by the meter. So the sensing element may be any material that exhibits a relatively large resistance change in the change in temperature with respect to the change in the temperature. So also the material used should be stable in its characteristics, that is neither its resistance nor its temperature coefficient of resistance should undergo permanent change with the use or age. That means whatever the material we are using for the sensing element, that should not vary its characteristics throughout the usage. That means the resistance variation of that particular material should be solely due to the temperature variation. It should not be affected with any other parameters like age or anything. That means suppose we are using multiple times, if its resistance is keep on changing for every time, then it cannot be used for our usage. So the material what we are choosing, that could be very stable material. So this is the construction how a resistance thermometer is should be constructed. So this is the place where we are connecting the sensing element. Okay, it senses the temperature and resistance of particular device will vary. And this is the lead support for this sensing element. And these are the connecting wires through which we are connecting it to the other devices, where you suppose if you want to connect this in the Wheatstone's bridge, this arm, one of the arms of the Wheatstone's bridge should be a resistance. So this acting as a resistance. Here we are connecting the bridge arms, and these are supporting mounting threads, sheath. The sheath is to protect this tube. Okay, so this is the lead support, and all these. This is the construction of a thermometer. Like how we are measuring the temperature of a body using the thermometer, the same construction. Okay, we are using some liquid type thermometers in our daily use to measure the temperature of a body. Okay, mercury we are using. So this is the place where we are connecting the sensing element, like this thermometer, resistance thermometer is placed in the one of the arms of the bridge, so that the fluctuations will be there. Until and unless there is no temperature variation, the bridge shows zero deflection. Suppose if at all any change in the temperature, then definitely there exists a change in the bridge balanced condition. So the figure shows the simplest type of the open wire construction of platinum resistance thermometer. Platinum resistance thermometer. Here we are using platinum. The platinum wire is wound in the form of a spiral on an insulating material such as a mica or ceramic. This assembly is then placed on the tip of the probe. This wire is in direct contact with the glass or liquid whose temperature has to be measured. So this wire, whatever we are going to wounded here across this tube, that should be connected with the temperature sensing element. Whatever we are going to measure for the temperature, where there we need to connect this element. So Platinum, nickel, and copper are the metals most commonly used to measure the temperature. Platinum has a stability with temperature variation of 260 degrees to 1100 degrees Celsius. So this we need to remember. Platinum, nickel, copper, these are the three materials that we are commonly using as a sensing elements. Okay, like mercury in the olden days we are using mercury to measure the temperature variation, so that whenever we are keeping the thermometer on any human body who is suffering from fever, then what happens, the mercury will flow, the mercury will increase its that means it moves upwards, so that the temperature we can measure it goes up to 97 98 or like that. So if any person is suffering from highest fever, then it may go to 100 or 101 like that. So that movement is depending upon the temperature variation. Here we are using any material like platinum, nickel, copper, those materials are commonly used. And platinum here, our aim is to measure in industries, especially these instruments are used for the industry, so that's why it must be stable up to 260 degrees to 1100 degree Celsius. The resistance of the platinum wire changes with a change in temperature of the gas or liquid. This type of sensor this type of sensors have a positive temperature coefficient of resistivity, as they are made from metals. They are also known as resistance temperature detector. So even if we can call it as RTDs, resistance temperature detectors, RTDs. If you are having any question to explain about the resistance temperature detectors, so you have to write the answer for the resistance thermometer. Both are same, resistance temperature detectors or resistance thermometers. So resistance thermometers are generally of probe type for immersion in medium whose temperature is to be measured or controlled. So this is about resistance thermometer. And the next one is thermistor. Thermistor is also temperature dependent resistor, where the temperature variations are going to be measured in terms of resistance variation. But the difference between the previous one and this one, resistance thermometer and thermistor, is resistance thermometer works with the positive temperature coefficient, whereas thermistor works with the negative temperature coefficient. So what do you mean by positive temperature coefficient and what do you mean by negative temperature coefficient? Positive temperature coefficient means in the case of resistance thermometer, what I explained, as the temperature increases, the resistance increases. Temperature decreases, resistance decreases. This is what the positive temperature coefficient along with the temperature. But in the case of thermistor, it is having a negative temperature coefficient, where as the temperature increases, resistance decreases. So thermistor is a contraction of the term thermal resistor. Thermal resistor, combinedly we can call it as thermistor. So thermistors are temperature dependent resistors. They are made up of semiconductor materials which have negative temperature coefficient, as I said now, which have negative temperature coefficient of the resistivity, that is the resistance decreases with increase in the temperature. Thermistors are widely used in application which involve measurement of temperature range. Here now it is 0 to 60 degrees. Generally thermistors are preferred for low temperature measurement, and the resistance thermometers are used for high temperature measurement. As we have seen in the platinum case, we have seen 260 degrees to 1100 degrees Celsius, but here thermistors are only meant for low frequency, low temperatures, that is 0 to 60 degrees Celsius. Thermistors are composed of sintered mixture of metallic oxides such as manganese, nickel, cobalt, copper, iron, and uranium. These are the materials generally used to construct these thermistors. So this is how the thermistor is going to be used in an application. So this is the place where we are connecting the thermistor in the circuit, and the variation of the, see, in the through this heating element we are applying some heat. Generally thermistors are very small in size, very small in size. These are having some advantages, like thermistors are having negative temperature coefficient, negative temperature coefficient. These points are very important. And second one is small in size, small in size, and negative temper, it is having negative temperature coefficient. They are small in size. Another one is low temperature measurements. Low temperature measurements. Okay, these points we should remember regarding the thermistors. Okay, the quite opposite is the case with resistance thermometer. They are larger in size and positive temperature coefficient and measures the high temperature. Okay, that's why as they are very miniaturization size, as they are having less in size, they can be incorporated in any circuit easily, or and they can be connected to any instruments easily to measure the temperature. So this is the circuit where we are connecting a DC supply, and because of this temperature variation of this heating source, the thermistor gets affected and changes the resistance so that the current will vary. Whichever the current flowing through this thermistor, because of no heat, and after applying the heat, the resistance will vary, so that the current flowing through this thermistor will vary, so that those fluctuations we can measure through this meter. See here, micrometer calibrated in terms of temperature. Same basic meter we have considered, but now it is calibrated in terms of temperature. So temperature variations we are going to measure here using the thermistor. So these are the different types of thermistors. Thermistors may be in the form of beads, rods, washer, and disc type. So this is the disc type, this is rod type, this is washer type, and this one is bead type. Very very small in size, and these two wires, everything is having different two contacting leads to connect with the circuit. Washer type is having, it should be connected like this. The thermistor provide a large change in resistance for small change in the temperature. In some cases, the resistance of the thermistor at room temperature may decrease as much as 6% for each 1 degree rise in temperature. So, for in a room temperature, for every 1 degree rise in temperature, there is a decrement of 6% in the resistance of this thermistor. So, this is all about thermistors and the resistance thermometer. They are quite opposite one each other. So one is a positive temperature coefficient, one another one is a negative temperature coefficient. One measures high temperature, one measures low temperature. And the resistance thermometer gives maximum in size, and this is a low in size. As it is, thermistors are having a low in size, very less size, they can be incorporated in industries very easily. Okay, see, if you see the disc type, rod type, washer type, bead type, these are the four different types of thermistors. They can be easily incorporated anywhere in the industries. Okay, so this is about resistance thermometer and thermistors. Thank you.